So here they say in the diagram here, O is a center, and then AB are points on the circle. Use Euclidean geometry methods to prove the theorem which states that this angle here, AOB, this angle here is going to be 2 times angle D here, which is an angle at center is 2 times the angle at the circumference. Okay? And then how will you approach that one here? What you need to do here is to construct. You are going to join OD. So that's the first thing that you'll do. Join OD. So you're going to join OD. And then from there, you're going to produce O, and then you go to something like E. After you join OD, now. After joining OD, or another way to do it, let's try it this way. We've never done it. You can say which you are going to construct a diameter DE. Again, if it's a diameter, it's going to pass through O. So you can construct, you will say which you are going to construct line. So you're going to join diameter DOE. So you just make this thing to be a diameter. And then from there onwards, this is what you're going to do. You're going to divide this thing here as O1 and O2. And then you're going to divide this angle as D1 and what then? And D2. And then from here onwards, this is what you're going to see. You're going to see something like this. I got this one here, it's going to be your D. In your D, you have what here? You have D1 again. And then here you have what? You have A. And then here you have what? You have your O again. And then here you have what? Your E. And then what you will see here is that I got this one, we already called it O1. If we call it O1, this thing here, it's a triangle, this one. Look at this triangle, ADO. Can you see triangle ODA, ADO again? This angle here is an angle outside. So we call it an exterior angle again. What will be this angle equaling to? Angle A plus D again. Yeah, so this is going to be equal to this one plus this one. So you'll tell them that. You'll tell them, okay, but now O1 is going to be equaling to angle D1 plus A. And then the reason why you are saying that is because you have exterior angle of a triangle. So you have exterior angle of a triangle. It makes this one to be equaling to this one. Okay, what else do we have then? But remember, what is OD? What is OD? OD, what is O to D? What can you call this line here? OD. It's a line from the center to a circumference. What do you call a line from the center to a circumference? Yeah, this one is a radius. What do you call OA then? What is going to be OA? It's a radius. So it means this one is a radius, this one here is a radius. These two are equal. If these two are equal, what can you tell me? What do you know? In a triangle, if you have this and equaling to this one, what can you tell me? Yeah, so it means D1 is going to be equaling to angle A again. So you'll say, okay, but now D1 is equaling to angle A, and then it's because we have angles opposite equal sides. So this one and this one, they're equal. So if these two are equal, again, instead of writing this thing here as angle A, you see this one again, I can replace it and put it as what? As D1. So it means, in other words, I can say something like this. I can say to them, okay, but now O1 is going to be equaling to something like this. It's going to be equaling to D1 plus D1. D1 and D1 are like terms. Okay? If you have D1 and D1, what can you say? You can say O1 is going to be equaling to 2 times D1. So O1 is going to be twice D1. Okay? And then you are going to tell them, but similar, if you look at the other triangle, I agree we still have this triangle. Whatever we did this side is also going to be applicable. I agree we did it for this side here. If we do it for O2, we're also going to get exactly the same thing. I agree we still have in similar. So tell them with similar in triangle OBE, D in this triangle, which is OBD again. It means O2, what is going to be O2? Yeah, we expect O2 to be equaling to 2 times D2. I agree we've already proven this thing here, which how does it work? I agree we're going to use an exterior angle again. And after using an exterior angle, we equate these two. And then from there, it means I agree the end product here, we've got O1 is twice D1. Then we can also see which O2 is also going to be twice D2. And then from here onwards, what you then see is the following. If we move on with this thing here, you can then safely say, but O1 plus O2 is going to be actually 2 D1. I get this one is O1 plus 2 D2. And then as you can see here, there's a 2 and then there's a 2 again. If there's a 2 and a 2, you can say which of these two things are common, and then you take out 2 as a common factor. And then if you take out a common factor, then you're going to be left with a D1 plus a D2, close bracket. And then if you check this, I agree this one is O1 plus O2. What is O1 plus O2? O1 plus O2, get this angle that they are talking about. It's angle AOB. So it means instead of writing this thing as O1 and O2, we can write it as angle AOB. Again, if you combine O1 and O2, can you see that? At the same time, what is D1 plus D2? ADB. Yeah, so you say which it means in other words, angle AOB is going to be equal to 2 times angle ADB, which is what we're required to prove for 5 marks. So where do you get your 5 marks? Construction, 1 mark. Exterior angle, 1 mark. Angles opposite equal side, 1 mark. This one is going to be twice that one, it's 1 mark. And then you're also going to get 1 mark here. And then all in all, you get your 5 marks.